Okay, so now we're going to do question 7. 7.1 says that Tandy decides to invest 45,000 Rand into the savings account. She charged an interest rate of R%, compounded half yearly. After 5 years, the investment matures and she receives this amount of 66,611. Calculate the interest rate, right? So we know that this is a compound formula. First of all, A is equals to P into 1 plus I to the power of N, right? And what we need to remember is this was the investment. So this is P, right? And this was the accumulated amount. So this is A, and the interest rate that is required is going to be I, and the investment was for 5 years. So this is going to be N, right? So you're just going to substitute everything in the formula. So we're having A being equals to P into 1 plus I to the power of N. Remember that I said A is equals to 66,611, and then P is equals to 45,000 Rand, and then I we don't know, but N is 5 years. And another thing that we need to note is that this investment was compounded half yearly, right? So this portion here is really important. So it's compounded half yearly, so it means it's compounded half yearly, right? So it's compounded half yearly, so which means we're just going to divide by 2 here and then multiply by 2 there. So let's just substitute everything in this equation here. So instead of writing A, you're going to write 66,000 Rand. 611 equals to 45,000 Rand into 1 plus interest rate we don't know, but we know it's compounded half yearly, so it's divided by 2 to the power of 5 years multiplied by 2 because it's compounded half yearly. And then we're going to divide, because we want this I here, so it's just going to divide by 45,000 Rand both sides. So it's 45,000 Rand, and we will have 66,611 divided by 45,000 Rand is equals to 1 plus I over 2 to the power of 10 now, because 5 times 2, and we still need what's inside, right? So we can multiply by 1 over 10 to remove this 10 here, so it's 1 over 10, and we will have 66,611 over 45,000 to the power of 1 over 10 is equals to 1 plus I over 2 now, right? So you're going to transpose this 1 to the other side, so you're going to have 66,611 over 45,000 minus 1 is equals to I over 2, right? We still need I, right? So we're just going to remove these 2 at the bottom by cross multiplying like this. So it's going to be 66,611 over 45,000 minus 1, and then you multiply by 2 equals to I. So I hope you can see that I didn't punch my calculator up until this point. The reason being is you don't want to be rounding off prematurely as you solve the problem, because it will be slightly different to the final answer. So you need to punch towards the end of your solution. So now that we reach this point of finding I, you can simply punch in your calculator this whole expression here. And if you round off to 2 decimal places, you should have I being equals to 0.08, right? Which would give you, if you multiply by 100, because this is a decimal, so you have to multiply by 100. Sorry, not 1,000, but you multiply by 100. It will give you 8%, right? So this is the interest rate of this problem here. Now we're going to do 7.2 here. The question says that on the 30th of June, on the 30th June 2013, and at the end of the month thereafter, Jonathan deposited 2,500 rand into the bank account that pays 6% compounded quarterly. He continues to deposit this amount up until the 30th of June, right? So he started at the depositing on the 30th of June, right? Because the statement says that on the 30th of June 2013 and at the end of each month, right? From the 30th and at the end of each month, he or she deposited, I'm assuming Jonathan is a he, so he deposited, yes, it's a he deposited 2.5 thousand right into the bank account that pays 6% per annum compounded quarterly. So we need to draw our number line to represent this information here. But let's check the question. How much money will Jonathan have in his account immediately after depositing 2.5 on the account? So we want to know the amount that he will have. Excuse me. So I want to know the amount that Jonathan will have. So these are savings, right? So these are savings of Jonathan. So we know very well that we're going to use the future value annuity because we want to know the future value, the amount that he would have accumulated if he made monthly installments or monthly payments, rather monthly savings, whatever you call it, of 2.5, right? So we are going to draw to represent the information. So we know this is our timeline. It starts at T0. T0 is the 30th of June 2013, right? So it starts here. So the payment of 2.5 starts here. And they end at T20, right? Why am I saying T20? Remember that it's from 2013 up until 2018, right? Simply do the math. It's 5 years, right? From 2013 to 2018 is 5 years, right? And remember that our interest rate of 6% is compounded quarterly, right? So the payments are made quarterly, or the interest that is earned, is accumulated quarterly, right? So if it's quarterly, it's going to be 5 times 4 being equal to 20. So hence I wrote 20 there, right? So it's not necessarily 20 years. It's just 20 payments made. We know that it's 20. It ends at 30 June 2018. So our future value formula, which is written like this: 1 plus I to the power of n minus 1 divided by I, right? So the future value is equal to, so we know the payments is 2.5, 1 plus our interest rate, it's 0.06 quarterly. So and what is our n? Remember that it started off immediately at T0, right? So if it's T0, it means now to find n, we're gonna say the 20 minus 0 plus 1. So the 20 is 20 minus 0 where it started plus 1, which will give you 21. So our n is 21. It's going to be minus 1 there, right? And then we divide by 0.06 over 4. So you're just going to punch your calculator the entire thing here and find the future value annuity, which would be 61,176.8 So this is the solution for this problem here. So now we're going to do 7.3. It reads as follows. On the 1st of February 2018, Genevieve, oh gosh, I can't pronounce his name. Sorry for butchering it. Genevieve took a loan of 82,000 rand from a bank to pay for her studies. She will make her first payment of 3,200 rands on the 31st of July 2018 and will continue to make payments of 3,200 rands until she settles her loan. The bank charges her an interest rate of 15% compounded annually, compounded monthly. 7.3.1, calculate how much Genevieve will owe the bank on the 1st of July. So we need to note that she took a loan of this amount of 82,000 rand on the 1st of so this is the loan. Let me just write loan here. Loan taken on the 1st of February 2018, and then she didn't pay after that up until it was the 31st of July. So that was the first payment. So normally when you take a loan from a bank, or let me just say in according to our financial maths, when you take a loan, you must make payment 1 month after taking the loan. So that's the normal way of paying the loan, right? But there are different conditions where you'd pay immediately if you want, or you'd miss payments, because once you miss payments, obviously there's going to be a problem with that. So in this case, she did miss payments because she was supposed to pay 1 month after taking the loan. So so this is the payment of, so this is going to be the payment that she made, payments of 3,200 rands to settle the loan. So fine. So now we want to know how much she will owe the bank on this date of the 31st, on the 1st of July 2018. So for us to solve this problem, we must draw a timeline to indicate. So we already know the amount that she will pay, the amount that she owes, right? So the loan is 82,000 rand, and payments that she made are she made payments of 3,200, right? 3,200 rands. Now want to know how much she'll owe, right? Let's first draw our timeline and indicate that at T0 it's when she took the loan in 2018, right? So she took a loan and didn't make payments up until we reached the 1st of July, right? Then that's when she made her first payment of 3,200 rands, right? Yes, that's what the statement says. So we can simply say from the 1st of February up until the 28th of February, provided it's not leap year, 2018, to the 30th of March. Let me just assume it ends on the 30th. And then we have April, 31st April 2018. Then you go to May 30 May 2018, and then this is June, sorry. So this is very important. I'm writing this because it's important. So remember, I said normally the payment is made here after taking the loan. 1 month after taking the loan, you make payments on the 28th of February, right? But she didn't make payments, right? And she didn't make payments here, she didn't make payments here, so started making payments here. So we need to calculate the missed payments. So I'm just going to shade the missed payments. So this is going to be 1. I'm just going to shade the gaps, right? 1, 2, 3, 4, 5. So these are the missed payments. So all of these green shades are missed payments. So you need to count how many are these green shades. It's 1, 2, 3, 4, 5. So it means now we have 5 missed payments, right? So we need to know how much she owes the bank, since she missed 5 payments. So what we're going to do is, we know the interest rate is equals to 15% compounded per annum, compounded monthly, right? So we're going to solve this problem by using the compound formula, because we want to identify the amount that she owes since she missed 5 payments, right? So it's P into 1 plus I to the power of N, and the loan that she took is 82,000 Rand into 1 plus the interest rate 0.15 divided by 12 because it's compounded monthly, to the power of 5. This 5 means the 5 missed payments, just so you know. And then you're going to punch your calculator. You should get 87,254.74. So this is the amount that she owes the bank since she missed 5 payments. Then now 7.3.2 says that how many installments of 3,200 Rand must she pay to settle the loan. So now we know the loan is 87,254. So we want to know the number of payments that she'd have to make if she pays 3,200 Rands, right? So we know very well that the equation for the loan is the present value annuity, which is equals to x into 1 minus into 1 plus I to the power of minus n divided by I, right? And the loan is this one here, which is 87,000 Rand, 254. So it's 87,254.74, right? Equals to, and then she made payments of 2,000 Rand. She made 3,200 payments every month. So it's 1 minus into 1 plus the interest rate is 15%, so it's 0.15 divided by 12, and we want to know the number of payments, so it's going to be minus n, right? Close bracket divided by 0.15 over 12. So now we're going to find this n because we want to know how many payments will she make. So what you're going to do is we're going to cross multiply, so it's going to be 87,254.74. Yes, it's 254.74. Everything is written correctly from here. So it's going to be multiplied by 0.15 over 12, this one here, and will be equated to 3200 into 1 minus into 1 plus 0.15 over 12 to the power of minus n, and close brackets. Then from here we're going to divide by 3200, divide by 3200, then you're going to have 87254.74 multiplied by 0.15 over 12 divided by 3200 equals to 1 minus into 1 plus 0.15 over 12 to the power of minus n, right? So what we'll do from here is, this is 5, just so you know, and we're going to transpose this one to the other side. So it's going to be 87254.74 times 0.15 over 12 divided by 3200 minus 1 equals to minus into 1 plus 0.15 over 12 to the power of minus n, right? So from here we just going to, because we want n, right? We want n, so let's punch this expression here in our calculator. So I hope you see that I always punch towards the end because I don't want to get premature answers, you know. So let's just first punch this huge number into our calculator. So you should get negative 0.65916. So it continues. Just gonna write it into 5 decimal places, being equals to minus into 1 plus 0.15 over 12 to the power of minus n, right? And then the negative will divide out. You'll remain with 0.65916 equals to 1 plus 0.15 over 12 to the power of minus n, right? So now we're going to use logs. So it's going to be minus n is equals to log of our base 1 plus 0.15 over 12 and then 0.65916 here. So you're just going to punch this in your calculator. You should get minus 33.55, which when you divide by negative 1, you get n being equals to 33.55. Because we want the number of installments, we can't write 33.55, right? You can just approximate and say n approximates 33 payments. So these are the number of payments that she will make to settle the loan.